Hello students, how are you? So this question is from AP Physics 2025. So the question says that students are investigating balancing system using the following setup. So this is a setup. The student have a spring scale of negligible mass that is fixed to one end of the uniform meter stick. So this is a spring system. The center of the meter stick is attached to the stand on which the meter stick has a pivot. So this is the pivot. There is a hook of negligible mass fixed to the top of the block of M naught. So this is a negligible mass hook and M naught. The hook can be attached to the meter stick through one of the small holes in the meter stick as shown in figure. So these are the holes. The student do not have a direct way to measure the mass of the block. The block cannot be attached to the spring scale. Okay. Next, it says that students are asked to take measurements that will allow students to create a linear graph. Those slope could be used to determine the mass m naught of the block. The question starts here. Describe an experimental procedure to collect data that would allow the students to determine m naught. So basically the mass of the block we have to calculate using the experimentation, and it says that procure to collect data that would allow students to determine. So we have to describe how the experiment would be done. See, first of all, understand that this question is from the torque. So this force into distance 1 will be equals to the force to the distance 2. So F1 D1 will be equals to F2 D2 like this. So we need data like this. So for this you have to say that we will put this hook into the different holes and we will collect data of the force from the spring scale. So for each of the hook there will be different values. So like this distance we know, like this is 50 centimeter, and this distance will be different, like this will be 10 and this will be 20 and then 30 and 40. So for different distances there will be different forces. So this will be the first part, collection of data. Include any step necessary to reduce experimental uncertainty. This is also very important because it also has one point for this. So for this you have to say that we will have to take more data. Like for 60 centimeter hook we have to take more data. More the data, lesser the uncertainty. So we will repeat this experiment again and again. So the B part says describe how the data collected in part A could be graphed and how the graph would be analyzed to determine M naught. So when we will have the data, we will say that this F into 50 will be equals to, you can take it as a small d into the force. Force will be M naught G. So M naught G. So this will be the equation. So we can write like this, like F is equals to M naught G by 50 into D. So this is one equation. We can compare it like y equal to mx, where m is the slope. So we can say that this is the slope and F, that is the force, is the function of distance of hook from the pivot. So you have to write like this, that force for the function of distance from hook to the pivot, where this slope will be, you can write the little space is less here, you can write like slope will be mass into gravity divided by the distance of spring to the pivot, that is 50. See, we are not converting this centimeters or here because both of the sides it is centimeter, so it would be cut off. So we are not using that. So this is the slope. From this slope, you can say that m naught value will be slope into 50 divided by g. So this is the one way. You can also go with, if you want, you can say that F is equals to m naught g d by 50. This will also give you straight line because this slope, that is y equals to mx, this is, first of all, this is a linear equation and it's the constant value. So at this time you will say that force is in the function of distance of hook from the pivot to the distance of spring to the pivot, because it is 50, d by 50. So both ways it is right, you would be marked for that. So now let's move to the next part. The student have an identical meter stick of mass m that is now attached to an axle that is fixed to the wall. The meter stick is free to rotate with negligible friction about the axle. The meter stick is suspended horizontally by the string that is connected to a spring scale of negligible mass as shown in the figure. So this is the figure. You can see this theta is the angle of the thread with the axle, and if you will keep on moving towards this side, theta will be increasing, decreasing. Okay, so the angle theta that the string makes with the meter stick can be varied by attaching the string to the one of the pegs located along the wall. The students use the spring scale to measure the tension Ft required to hold the meter stick horizontal. So this meter stick is always horizontal and we are calculating the data and recording the data, we can say. So this is the table. So with increase in the degrees, the F values has been recorded. So it says that the student correctly determined the relationship between Ft and theta, which is given by this. The student create a graph with 1 by sine theta plotted on the horizontal axis. So they have now drawn the graph. We can also, if you don't know, I'll just tell you that from where this is coming. Just wait, because that's also important. See, this is the center of mass. Center of mass will be downwards like mg, and this force will be like upwards. And if this will be t here, and this will be theta, so when we will have components here, it will be t sine theta. So this question will be from like rotation. So this will create a clockwise and this will create an anti-clockwise. So this is from 50, this is from 60. So we can say that mg into 50 equals to F, or you can say t sine theta, that is the upward force, but the distance now is 60. Okay, so or you can take this F in place of t because F is given in your question. So F is now equals to 0 and 0 goes off. So F is equals to 5 by 6 mg by sine theta. So this is how this is solved, because in some of the questions they can ask you directly. So it is very important to learn from where they are getting this. So now they say indicate what measured or calculated quantity could be plotted on the vertical axis to yield a linear graph. Those slope can be used to calculate an experimental value for the mass m of the meter stick. So first of all, you see that they are saying that linear graph is there. So we can change like this. Ft will be equals to 5 mg upon 6 and 1 by sine theta. So now this is like y equals to mx, where this is the slope and this is the x-axis, this is the y-axis. So for this, if you will say that I am putting the vertical axis as ft, so the slope will be 5 mg by 6. For that, the mass will be 6 into slope by 5g. So you can make any of the vertical axis. Like if you will say that 6ft, you will put 6 here, then your slope will also change. So this is for the first part, and now on the blank grid provided, create a graph of the quantities indicated in part 1 that can be used to determine M. So now we have that thing. Now see, this is the data and we have to calculate it. Okay, so I'll just write it again: 22, 31, 36, 22, 31, 36, 45, 80, 45, 80, and the forces is 21, 17, 13, 21, 17, 13, 12, and 8. Okay, so this is the theta value and this is the force value. So first of all, this is 1 by sine theta, so we have to calculate 1 by sine theta, and this is the F on the y-axis. So now we need the calculator. Let me check the calculator. Okay, so 22 sine 1 by, so this is 2.66. Okay, and then we have 31 sine, that is 1 by 1.94, and then we have 36 and sine 1 by sine 1.70, and now 45 sine 1 by sine 1.41, and then 80. Oh, sorry, 80 sine and 1 by sine become 1.01. So these are the values. Now we will plot it. So this is 21. We can mark here like 5, 10, 15, 20, and 25. So 21 with 2.1, 2.6. So 2.6 is here and 21 is here. Okay. Or yeah, this one. Then we have 17, 1.9. 17 is here, 1.9 is here, 1.9 and 17. Then 13 and 1.7, 1.7 and 13, 1.7 and 13 is here. Then 12, 1.4, 1.4 and 12, like this. You can mark like this also. And then 8 and 1. This is 8. Okay. So now we need to make a line of them. So this will be the straight fit line that we need to draw. Draw a straight fit line for the data graph. Okay. Using the best fit line, calculate the experimental value of M. Now we need to calculate the value of M. Okay. See, to calculate the value of M, we need this. So the slope is, first of all, calculate the slope. Slope is what? Like this is 21 and this value is 2.6. So like what I'm using is I'm using y2 minus y1 upon x2 minus x1. This is the formula for slope. So here the y2 y coordinate is 21 minus 17 and 2.6 minus 1.4 1.9. So it will be 4 divided by, okay, 2.6 minus 1.9. No, sorry, 2.6 minus 1.9. 0.7. 0.7. So it is 5.7. So m is 5.7. Okay. So if slope is this, now we will calculate m. So we will do more maths. If slope is 5.7 equals to 5 into m into 10 upon 6. So now we will do maths again. So it would be 5.7 into 6 divided by 50. 0.6. 0.6 could be the mass, or we need to check a little bit again for, yeah. So calculate the experimental value for mass. So it would be 0.6. So this is how we have to solve. You can do it little again, and if there would be any mistake in it, you can tell me and we can rectify later. So thank you for being here, and if you still have some doubt for this question, you can ask me. These are a little bit lengthy questions. Okay, thank you.